Hi, we are going to talk about database concepts in financial engineering. And if you are looking for any financial engineering kind of a work that would involve database concepts, then this refresher would be helpful to you. So there are many technologies that are used in database management when we are dealing with data that is pertinent to finance. The technologies that we use include MATLAB, SQL, C++, XML, and Java, and each of them have their unique perspective attached. So for example, if you are doing the calculation of Greeks, or if you are doing the calculation in securitization where you want to use a lot of quant like copulas, like different kind of distributions, then that work could be done in MATLAB. But when you are done with that, you can store that work into a big database that is again stored into the MySQL database or any other database. And when you look at automating a lot of things here, you can look at C++ that would do a lot of thing in database, pulling things from here and there, and interacting with SQL at a very fast rate. The XML database most of the time used in online data that is stored, and the Java is the advanced object-oriented programming language. So a lot of data that we handle here are based on securitization. By securitization we mean that it might be some collateral debt obligation, mortgage obligation, maybe some something related to do with different kind of loans that are securitized, and how we actually capture all those things. So if you have invested in a CDO, or if a bank has invested, investment bank has taken a position into a CDO, then he needs to make sure how the entire CDO would move and what would be the Greeks in that regard. So the bank needs to find out and calculate those things, where it would require MATLAB, because you need the partial differential equation once you have all the data with you. So in that respect, MATLAB is the mathematical engine. The SQL may be the database part where you would store all the data. So the first step that you could do in learning this subject is install MySQL. In the coming classes I'll talk a little bit about that, and integrate that with MATLAB, so that whatever happens in MATLAB gets stored into the SQL. I have made some videos that does the same thing. It talks about how to integrate MySQL to MATLAB, so that the data that you bought in the MySQL could be called by MATLAB. In a way, the framework that could work or that might work would be you use C++ and SQL to extract data between XML to SQL, or do different kind of operations, because when we talk about C++ we are talking about lightning fast speed. And once that is done, you can then use MATLAB to link SQL and do all those kind of computations. So the person who is using MATLAB might not be worried about a lot of things in terms of database and object-oriented programming. He might be a person who is more concerned about the quant part, about the Greeks part, about whether that data makes sense or not, and things like that. Whether he want to Winsorize some data, or he want to make some changes so that the data could reflect the real risk and things like that. So we do those things to improve the data management efficiency, to capture bulk data. And many of the times we have all the data being stored in spreadsheets, and we would like to convert them to relational database. So when we look at the conversion from a spreadsheet to a relational database, the first question arises, if you are hearing this word for the first time, is what is relational database? So relational database is a way to store the data into a more efficient manner, and that's what we are going to look here in this session. So the 4 topics here that we would like to look at, and those are important when you start the database learning for the first time, is to understand 4 points. I'm talking this in terms of a job interview, or in terms of whether you are trying or planning to move into financial engineering and you want to know the database concepts that you could see here. So we'll slowly delve into 4 topics broadly. The relational database, what does that mean? The ER diagram, the entity relationship diagram, the different kind of joins that happens in SQL, and the normalization of data. So these are the four things that you would see extensively in any job that you would do which involves database into financial engineering. And how to link that thing into MATLAB and how to run that from MATLAB to get the right data is again one different aspect of the entire equation. So first let's look into what is a relational database. So the relational database consists of a collection of tables that store particular set of data, and the invention of this database system has standardized the way in which the data is stored and processed. And this is actually derived from the principle of relational algebra, which came from the father of relational database known as E.F. Codd. So many of the times we use relational model concepts, and again it was discovered in 1969 by Edgar Codd, EDGAR. So 69 is a lot time backward. So the idea here is to describe a database as a collection of predicates over a finite set of predictable variables, and describing constraints on possible values and combination of values. The content of this database at any given point of time is finite logic of database, that is a set of relation and one predicate variable such that all predicates are satisfied. So when we delve into this more, we can learn more about the relational database. The purpose here is to provide a declarative method for specifying data in queries, and this was first implemented by Codd into the IBM. The most front end thing that we are going to see here would be the SQL databases. So the object oriented relational type of model is something that's evolving, and when we delve into this we can check out the other parts. So we move to the relational algebra expression. This is something from the quant part or the maths part. So there are some unary operation that could happen, like binary operation. We might do some operations with the input and output, and that's where the relational algebra comes into play. So when we look at this, when we want to operate on two relations, that becomes our binary relation. And then we have the select operations, we have the other type of operations like displaying, like specifically selecting some of the things. And again, when we move more into this, we have got the things that we know better, that is the union, the intersection, the minus, cross product, renaming. So that's where those all mathematical relations come into play, and all these things will be applied to the relational database, and the thing that I'm talking here is known as the relational algebra, which is again used to create that. And the next part here, which is the third part on your screen in the quiz, is join. So joins are used to combine the information of two relations which have at least one field in common. It is one of the important operations of relational database management system. A join operation can be defined as a Cartesian product between followed by a selection or a projection parameter. So don't worry about the jargon. The idea here is that we are joining two databases or information in two databases. The new thing that's added here is the relational part. The different forms of join that we can find here is conditional join, equi-join, natural join, and outer join. And these joins could be practiced on the SQL with a simple data. So when we move ahead and we move to the second technology, SQL, we will see we use three commands mostly, if you might have heard, which is the select, from, and where. And select is a command from the DML language that is used to select specific columns. The SQL query starts with select keyword followed by the list of column that forms the resulting relation. So select distinct selection list from a from list, where, and the qualification. So the distinct, the use of this keyword is to prevent duplication of rows. When this keyword is used, all the tuples of the tables are unique and there is no redundant data, although this is optional. Then we have the select list, the collection of all these column names that user want to have in a new rows, and qualification, which is a Boolean expression which represents a condition or a logical connectiveness, and also comparative operations. So that's where we can use the select from. The other thing that we might do in the database is understand the rules of the queries and create more tables. So to create table, again the idea is simple here. You will use the create table command followed by table name, column and the data types. If you are doing that into the graphical user interface, then probably I'll show you how to do that into a MySQL. So installing and setup, installing the setup of the databases, making the connection, making it live with the password and the username, again that all goes into the MySQL. So the DML operations are select, insert, update and delete. So those are the operations that we'll see more common. The other, for example, insert means inserting into some employee table where we want to insert some particular aspects. So insert into employees, first name, last name, age, address, city, and then the values into the inverted commas. And then we have the update rows. It's quite again similar. And then we have the delete command that would delete. Now then there are commands in DDL. By DDL I mean data definition language, like create, alter and drop. And then we have the set operations like union, intersect and a lot of them. Now remember that there is something called null. So many of the times in the databases you will see a null, which means no value. So you have to define whether you want to allow null values in something or not. So once you do that, that part could go null. So when we move down the complexity part, and here is something that you can expect in more interviews or in more advanced aspect, is complex queries. So you can create complex queries by using more than one select. At the highest level, the query select statement, which consists of query expression followed by operators order by clause. At the next level, we can combine different query blocks into a single expression with union operators. Lower still, inside each query box is an optional search condition, and which can contain predicates that incorporate subquery. So subquery is always a single query block select that contains other subqueries but cannot have a union. A query expression can contain maximum of 16 query blocks. We can create complex queries using the following, and there are three things here. The union operator, which allows you to take union of all rows selected by the query blocks in the select statement. Subqueries, they are also known as nestle queries, and special predicates like any, all, some exist, in which allows you to compare the values of an expression with value of each structure and subqueries. So when we delve more into this, we can see the kind of things, and the last part here, again moving back to the joins. So SQL joins are used to query data from two tables based on relationship between certain columns in these tables. A join is a means for combining fields from two tables by using value common to each. SQL is a relational database query language, and as such one of the most important features is its ability to retrieve information from several different related databases. If you observe the words several but different related databases. In relational database terms, this process is called a join. The table to be joined are named in from clause and select from each table. The relationship between the tables in a join are defined by a predicate in the where clause. So SQL has 4 joins: inner, outer, left and right, and of course you can go and check those in some SQL class. So this is a little bit about what kind of things that you can see in the database concepts. If you were to focus and if you were to read this in just one reading, then you can start with probably relational databases. You can do a question or a quiz of ER diagram. You can do a quiz of join, and you can do a quiz on normalization of data. So I think that would equip you in a way to tackle these kind of interviews or these kind of jobs, or if you are doing a master's in financial engineering, that this would actually help you to prepare yourself for the course that's coming to you in future. Alright, thank you for watching this video. I hope this was helpful.